Hello everyone, a very warm welcome from Cognifront. Mechanisms and machines are very interesting to learn as well as to teach. So, here we present you the Mechanical Engineering Teaching Tool software. This is an excellent tool covering all the fundamentals and understanding of mechanical engineering. There are 8 sections in this module, each with very unique features to offer. We'll go through each one of them one at a time. First, we have the theory animations. Clicking on this thumbnail below, we see that there are a number of 3D animated audio as well as visual products. Right from thermodynamics, boiler, entropy, turbine, refrigeration, conditioner, thermal power plant, Newton's law of cooling, and so on. I'll show you one of the video.
Wind power plant. In this session, we will define wind energy, study the working principle of wind power plant, and learn the application of a wind power plant. Wind energy.
We all know that wind energy gets converted to electrical energy by the wind power plant. Here, the turbine uses wind to generate electricity. The hub and the blade can be together called as the turbine or the rotor. There is an engine house behind the turbine and it is called as the nacelle. Nacelle is mounted on the tower to get more energy. The rotor starts moving as it is connected to the main shaft. It spins the generator because of which the electricity is produced. This electricity is then given by the transmission and the distribution line to the homes, hospitals, industries, and so on.
Wind power plant may consist of 2 to 3 blades. The wind will cause the blades to rotate, which in turn will rotate the generator. Next is shaft. The hub is mounted on the main shaft. The rotation of the blade causes the shaft to rotate. If the wind blows very fast, then brakes can be applied to control the speed of blades and shaft. Next is the gearbox. This can be used to increase the output speed. Next is generator. The high-speed rotating shaft is connected to the generator. Because of this, generator rotates and electricity is produced. This electricity can be stored in batteries and can be used whenever necessary.
So, as you see, this helps in the understanding of the complex mechanisms and the concepts. There is another video. Actually, there are two videos regarding the electronic control unit.
Inputs to electronic control unit.
So, in the starting, they have shown the history.
Data. For example,
So, what happens here is when the car hits the wall, a signal is sent by the ECU, and at the time of the collision, the sensor instructs the ECU to inflate. So, we see how the ECU plays the role of the decision maker in this system. Further, there are many other parameters which are monitored by the ECU.
vehicle temperature, exhaust temperature, inlet manifold vacuum, throttle position, engine RPM, vehicle speed, crankshaft position, sensors that follow its principle of working. Potentiometer type of throttle body Note the valve position changes, position of the wiper also changes.
So next we'll move on to the animated solved example. This section contains animated solved example which helps the students to understand how exactly they have to solve the problems given. I'll show you one of the video.
First law of thermodynamics.
So here as you see the problem statement is given. Some part of the problem statement is also highlighted which shows the students that these are the points they must take into note while attempting a problem. Teachers can save their efforts of writing this long problem statements and the answers in the blackboard. They can also save the repetition time. For the next day they can just project this video on the classroom, and then the students will get a revision about the topic as well.
Given that the volume is doubled after expansion of gas, the piston displacement from top is the energy stored by the spring is calculated as the product of force and the change in length. Therefore, we get energy stored is equal to.
Next we have the step-by-step solved example. These are the non-animated module, but here the steps are given such that even an average student would easily understand the topic. So the question is problem statement is given and then the solution is given. You can also embed this in your lecture. I will show you later how to embed it in your lecture. So the solutions are also explained in the easiest manner. Next we have the visual glossary. Here also there are many visual glossary given. So this section helps the students to visualize these components. I would say the important components of mechanical engineering. So students must know these components. I'll show you one of them. Here this is a screw compressor. So as you see there is a audio, there is a visual animation as well as a glossary is given to the right. So here I can play this video. This is a 3D visual of a rotating screw compressor. There is color coding of both the inlet and the outlet ports. This also shows the parts of the screw compressor. We have audio as well.
Screw compressor. Screw compressor consists of two helical screws, inlet and outlet ports. Here you can see one screw has concave inlets while the other has convex helical inlets.
So next to it a glossary is also given. Next we have another example of a roots blower. Here also the animated video is given of a roots blower. The parts are also shown. Here it shows how the air is taken from the intake port and gets suppressed and how air moves from the intake to the delivery port. There is also an audio
Rotary compressor.
and the glossary is given. You can also embed this in your lecture. I will show you later how to do that. Similarly, next we have the Machines Explorer. Here all the technical details of 6 different machines are given. First we have the lathe machine. So we all know what is a lathe machine. Lathe machine is a machine tool. So it rotates a workpiece about an axis of rotation for performing various operations, be it drilling, cutting, turning, and so on. So here teachers can turn off and turn on the labels. They can turn off the labels and ask students to identify the parts of the lathe machine. Next we have the accessories and attachment. So here along with the visual, a glossary and an audio is given. Similarly, there is the carriers and catch plates, chucks. I'll play the audio of chuck.
by means of a backplate. The backplate is screwed on the spindle nose and chuck is bolted on it. Chucks are used to hold rotating jobs. Any job having short length, large diameter and irregular shape can be held quickly and rigidly in a chuck.
Similarly, a face plate, angular plate, mandrel, rest. Next we have the operations. Here there is video of every operation, be it the centering operation, turning operation, taper turning operation, chamfering operation, thread cutting operation, facing operation, grooving operation, parting of operation. I will show you one of the video of an operation. Let's take taper turning. So we can see how a taper turning is performed, operation is performed. Next we have the application. Here the applications of the lathe machine is given. Next we have the classification of the lathe machine according to speed lathe, engine lathe, bench lathe, tool room lathe, capstan and turret lathe, and so on. Next we have the line diagram. In exam this question is often asked. Students have to draw the lathe diagram. Next we have the animated visual of lathe machine. So by dragging the mouse you can see the whole lathe machine. Next we have the drilling machine. Here also we can label the parts of a lathe drilling machine and drag it, and we similar technical details of the lathe machine are of the drilling machine is given. Accessories and attachment, operation, application, classification, construction detail. So all the technical details are covered. So here we have the technical details of the grinding machine, milling machine, CNC machine, IC engine. Next we have the mechanisms explorer. So in mechanical engineering, mechanism is one of the important topic for designing. So mechanism is something that transforms input force and movement into certain output force and movement. So here we have a video of 4-bar chain mechanism. So for different inversion, although the motion characteristics are entirely different, the relative angular displacement of the member remains unchanged in respective of the link chosen for the frame. So here it is a video of a type 1 linkage, similarly of type 2 linkage, type 3 linkage and type 4 linkage. There is also an audio given.
4-bar linkages make the simplest closed-loop kinematic linkage.
Next I will show you how to embed these videos or audiovisual videos in your PowerPoint presentation.
Introduction to thermodynamics.
Click on
Welcome
embed in
everyone.
your
In
lecture.
this session, we shall focus.
Now the link is copied. Go to your PowerPoint presentation. I will take a blank presentation. Now here I will give the topic as mechanical engineering lecture. I will take an icon. So shape, I will take it as a rectangle. Now click on this rectangle, go to insert, go to action, click on run program, and the link that you had copied, paste it here. Control V. Click on OK and play the presentation. So now when you click on this rectangle, this dialog box will reopen. Click on enable. So the
Introduction
animation
to thermodynamics.
has directly opened from your presentation. I'll close this presentation. So that's how we have to embed it in our presentation. Next, we have the lecture plans. So these lecture plans are editable. As soon as I click on the lecture plan and the topic, here the presentation has directly opened in my PowerPoint presentation. You can edit these lecture plans. You can edit the PowerPoint presentations. Next, we have the 3D stereo visuals. So this is one part of a module which has been especially allowed by the students. So here with a 3D, you will need a 3D goggle to view this. So you'll feel the difference when you are using a 3D goggle and when you're not using a 3D goggle, because when you're using a 3D goggle, it will appear as if the parts are coming alive from the screen. It's very a lively experience. That's it. Do submit your feedback at info@cognifront.com. We would love to hear from you. Thank you so much. Do explore this.